This conference will now be recorded.
Hi everyone, my name is Vishal. I have an experience of industry and I'm a back-end engineer. So where I have played the roles from synthesis to sign off. Okay, and today we are going to be discussing about the back-end demo. Okay, that is like PD demo sessions we are going to be handling today. Okay, so before going forward, my always the first question, why VLSI? Why VLSI? Guys, why VLSI? Why this has changed? Am I audible?
Yes, sir.
Yes, yes.
Yeah. So why VLSI?
To reduce the size of the chip,
To reduce the size of the chip. Okay. Next.
To
we can
reduce power.
import.
To reduce power, reduce size, improve functionality.
Okay. Okay. So let me ask one other way. Why did you choose VLSI? Why did you choose VLSI? The term which you have provided is for what is VLSI? Yeah. Go ahead. See, it's a friendly session, so please be comfortable of giving your answers. Okay.
Hello. Hello, good morning.
Yeah, you're audible.
Yeah, so there are many good career opportunities in VLSI. So
Okay.
we have chosen.
Okay, so career opportunities and indirectly I will be saying is like money. Okay, and few of them are like so eager enough to work in an hardware industry which is embedded with IT. Okay, so there's like CAD related tools to be working for the development of hardware requirements. We will be going for this particular VLSI. Okay, if I'm not wrong, that might be the case. One. The second one is like for those who have studied electronics related, they want to enter into electronics with an higher package, so they might choose this. And for those who are eager enough to work in the same industry, electronics, VLSI, so they will be choosing this particular field. Okay, if I'm not wrong, that might be the answer. My answer is like salary. Okay, initially. Okay, now I'm an EC background only, so that's why I have a little bit of my core touching into this particular part. Now, so when I asked what is VLSI, you said it's like for reducing the power, timing, area, right? For that particular purposes, we are going into this particular VLSI. But those three terms actually come under a category of IC. Okay. Of the IC. So what is IC?
Combination of
Com
different
combination of transistors.
different gates, transistors.
Right.
Combination of
Combination
analog
of
and digital
transistor,
circuit.
or let's say like multiple
Uh,
transistors into multiple transistors embedded into a single area to perform a particular task or multiple tasks. Can I say that?
yes, sir.
Right. So, so now from this particular term, that is like to perform a particular task or multiple tasks, we have two types of flows. Okay, we have two types of flows that we will try to look into it. But before that, what are the types of ICs you have heard about? So we know, right, based on the amount of transistors embedded into a particular area, we have different types of ICs, right? What are those?
Analog and digital ICs.
Nah. I'm asking like if based on the amount of transistors embedded into a single area, we have that particular terms, right?
Small scale integration, medium scale,
Ah,
large scale.
correct.
Mm,
Small scale integration,
small scale, medium scale
MSI,
integration,
yeah, medium
large
scale
scale
integration,
integration, very large scale integration, very large scale integration.
right?
Say,
And like that we have is like ULSI, GLSI, like that we have coming terms, okay? So they, because our particular logic into a particular area is getting increased more and more in the day by day basis. So this particular terms like SSI, MSI is getting changed. All right. So when we are talking about SSI, it has is like 10 to 100 transistors, right?
transistor. Yes, sir.
So which will be example is like basic gates,
And
uh,
or
like
gates,
your NAND, NOR,
basic
basic
and
gates.
or
These are
or gates.
like, hmm. Okay, next is MSI. So I'll tell you why we are discussing about this as well. There is an relation. So what are the examples of this? MSI?
Mm.
Circuits which are formed with the help of this particular basic gates or basic flip-flops, right?
Flip, uh,
Like counters,
decoders,
registers,
encoders.
uh, decoders, encoders, all that will be coming under this particular category, MSI. So next is LSI. LSI will be having us 1000 to 10,000 transistors we are having in that particular area. What will be the examples? Processors. Okay, to be more specific, we will be having it's like 8-bit processors. Next is VLSI, where we'll be having it's like 10,000 to 1 lakh. These are again will be RAMs, ROMs, all that into this particular VLSI domain. Okay, 16-bit processors. Okay, and let's keep it like RAM, ROM, and so on. Okay, so now ULSA is like from 1 lakh to greater than it. Okay, so now when we are having this particular different categories, okay, now for example, let's take our particular phone itself. In our particular phone, what all modules do you have? Let's say like what are the different types of circuits are present inside our particular phone?
They're like memory,
Memory circuit, yes, perfect. Next,
processing. It's like a camera module,
right?
Read and write options.
Read and write options,
then display options,
display options,
LED option.
Antennas.
antenna,
pro, processor circuits,
processing circuits. So let's keep it simple like
Timing
camera
circuit.
modules, processing circuits, uh, power controlling
Timing
circuits.
circuits.
Sorry,
Timing circuit.
timing circuits. So that's what we are telling. It's like processing. Okay, inside that particular processing, we have that particular picture coming in. Okay, so first is like one second. Okay, yeah, something is wrong. I'll do type. Major part is like network module, camera module. As we want is like power controlling, power modules, and as we want to see it, display modules, audio and video, and as we want the controlling, processing, the data processing or signal strength processing, whatever it might be, the clocking, all that I'm just categorizing it under one category, that is processing modules. And next, if it's a 2G phone, we have is like keypad, right? So keypad module we have, and nowadays touch we have. So touch related. So like that, we have different sets of modules, right? So now, okay, memory modules, I forgot to mention that. So like this, we have different sets of modules. For example, okay, for example, let's say like I'm considering only memory module. In memory module, what are we trying to do?
Store the
Storage.
information.
Store,
Store the.
storing and restoring of the information, right? memory modules, I'm trying to store that information into the uh, RAM or ROM or
Device.
SSD, like that. I'm trying to store it, and whenever I require it, I'm taking from that particular memory, right? Read and write operations we are performing. Yes. So
Yes.
now when I'm trying to read and write that particular, if let's say I want to protect that particular, that means I need one more module like encryption module also to be included over there.
Yes.
You want some of your files to be protected, right? At that time, you will use some encryption modules. So that means there is internal processing again there. For that particular internal processing, like encryption data to be occupied on that particular file, I might use is like basic gates or registers, like that I will be using there. You're getting my point, right? So whenever we are going with respect to the advancement of the circuits, we are not stopping the usage of SSI, MSI, LSI, VLSI terms. Okay, with the usage of that particular basic circuits only, we are developing big circuits. So don't miss the basics. That's what my point is. Okay. So whenever we are considering any bigger circuit, I'm forming that particular bigger circuit based on this particular basic circuits only. And this big small circuits combined together, we are having this particular different terms, ULSI, GSI, like that you will be going further stages. Clear?
Yes, sir.
All right. Okay, if anyone is getting confused, please let me know. I'll stop there itself. Okay, so why VLSI? I'm choosing VLSI because I'm an electronics domain or my salary or whatever it is. It's your own opinion. Okay, that's why I kept one term VLSI. Now, so now to be more accurate, when you get to the terms, let's say like why VLSA, or let's say when you start studying everything, you will be able to know is like, okay, you will be able to know is like how the internal circuitry is able to uh, follow my requirement. Okay, let's say whenever you buy a phone, you will be observing is like what is the RAM, what is the processor, right? Whether it is what, at what frequency it is getting operated, like 8 quad, quad core or octa core with 2.2 gigahertz, and what is the refresh rate of the display. So like that, you will be able to observe each and every category, right? When you buy a phone or when you buy a laptop, what is the processors, or what is the RAM, what is the memory, like that you will be having is like different categories, right? So now when you get into this particular industry, you will be able to get to know is like in that operation, okay, for that particular operation, how much amount of area is getting occupied, how much amount of power is getting occupied, okay, what is the frequency of that particular internal module, like that you will be able to know is like in-depth information. That means you might see is like the internal of that particular chip, not transistor level. Again, I'm telling here, you are not going to be working on the transistor level. you will be working with a term called as black box. So, how many of you have observed ICs when during your engineering? How many of you have saw that particular ICs during your engineering?
So like basic ICs you can saw in the during lab hours like AND gate, OR gate, NOT gate.
Correct. So whenever you have observed it, it will be having like only a structure, right? It's a rectangular
Yeah.
shape. At
Yes,
which
sir.
side we need to keep it top, that only way. So same format, you will be able to see it in the tool. Okay, that is like you will get an understandable document of that particular for AND gate, for OR gate. What is the voltage, temperature, process information of that particular IC through a document, and you will use that particular IC into your design. Clear for everyone? So, when you start performing this particular VLSI, you will be able to get a knowledge of how to optimize the design with respect to. Always remember these three major terms in VLSI is like power, timing, and area. For this particular optimization only, we are going to be performing VLSI. Clear?
Yes, sir.
Is it clear for everyone so far?
Yes, sir.
And also, you will get an understandable knowledge of different technology nodes, okay, and also about FinFET technology. Nowadays, we are using is like FinFET, and we have gone beyond FinFET also. That means like CMOS, it's outdated. Now we are with FinFET. FinFET is also an basic of your CMOS, okay? And now we are going beyond that particular FinFET based on the controlling level we are changing it. Okay, this is what you will try to get it from the knowledge when you work in this particular VLSI industry. Different categories of transistors. When you go to level, it will change. It's not like everyone should get this knowledge based on the let's say position you are working. You will be having a change in the knowledge occurrence. Okay, clear for everyone so far? Any
Yes, sir.
questions or any confusions?
No, sir.
Okay, perfect. Now, when I started with VLSI explanation, I said like it is used to perform a particular task or multiple tasks, right? Based on that, we have two different flows. When you want to perform a particular task, that means the IC is used for performing a particular task. What is the term we have used during engineering? What is the term we have used to perform any IC to perform a particular task? What is the term?
Fabrication.
Guesses? No? Okay, so I'll just give that
Functionality.
ASIC. application specific integrated. Remember now? Application specific integrated chip, or let's say integrated circuit. Correct? And this particular ASIC, which means like it is used only for performing a particular task. That means if I want to store the memory, I'll store it. If I want to open the door, I'll just open the door. That means any circuit which is an application specific, or let's say to perform a particular task only, we are going to be using this ASIC flow. Okay, to perform a particular task. The next is SOC, system on chip.
On chip integration.
Correct. So, which is an integration of multiple ASICs. Okay, SOC means integration of multiple ASICs. So, based on this particular integration of multiple ASICs, right? The type of design will vary. That means how you are going to be performing your ASIC flow will vary. Okay, clear for everyone so far?
Sir.
Yes, sir.
Okay, the next part is ASIC flow. There is only a small change between ASIC flow and SOC flow. Okay, that I will give you what is the difference also. But let's go first one by one. ASIC flow. How many of you have heard about this particular ASIC flow terminology?
It's like a different process of integration of chips.
Okay,
Design flow.
Top-down process
so
and bottom-up process.
I'll just make it simple. When you want to buy a phone, again, I'll come to that particular task. What will be your first step to buy a phone?
How to see the specification of each mobile device.
Correct. That means like to see a device, or let's say like you have to decide what are the specifications you need first. Based on that only you will start your search.
Like battery, RAM, speed of
Performance,
the.
Yes,
performance
yes,
storage.
Cost.
correct. So first is that, as you have all said, timing, camera, area, battery backup, um, so camera specifications. So like that you will look into it, right? Audio quality, whether it is Dolby Atmos or not. So like that you will look into it. Correct? That means like the first step I should be always having is specifications. Once you got the specifications, what you will try to do next?
Fast verification.
Sorry? Faster verification, or let's say like what else we will try to do. I'll try to search in Google, na? I got the specifications. Phones with 8 GB RAM or 16 GB RAM with 256 GB of ROM and octa-core processor. So like that we will try to search in Google. Now, okay. So first part is specifications. It's done. One, okay. How many of you are familiarized with coding?
Yes,
Basic
for
coding like very language.
Yeah, any coding language. Okay, or let's say like during your engineering, when you are trying to learn C or C++, or let's say during your schooling, they would have started with basics of programming, right? So whenever we, or let's say teachers give us um, write a code to find whether the number is even or odd, what will be the first step they will try to ask us to do by seeing the question? Will you start writing the code first itself, or will you perform one step above it?
something
Take the
like a
input.
header or planning.
Planning, perfect. So that planning terminology,
You
can
have
I
to draw the
say here?
flow chart. You have to draw the flow chart
Correct.
before doing the code.
Yes. Algorithm, writing down the algorithm, or the form of words, or forming a flow chart. Correct? That's what we will try to do. That's what one of our friends said in another term is like planning. So once the specification, okay, now I'm coming back to our particular industry. That is like same method. Once I got the specification, I need one experienced person to understand what all modules can be used for that particular specification, and how much power and everything timing will be requirement will be decided. For that planning, I'm giving a name called as architecture. Okay, for that particular person who is going to be deciding the specific based on the specification development of your chip. Okay, how much modules can be used, what all modules can be used. Okay, and what will be the power requirement of that particular module, how can I reduce it. Okay, all that particular information, this architecture person will be able to handle it. Okay, clear? So architecture engineer is the engineer who is highly experienced. Okay, who is highly experienced, and he will be able to handle all the each and every design area, not area. Let's keep it like power requirement. How can I reduce it? All detailed information he can be able to give you. Okay, the complete information will be known only to this particular architecture. Okay, if you have any query, you have to reach up to him. Handling of your chip. Okay, specifications to architecture. In architecture, he will just do majorly is like he will decide for that particular specification 16 megapixel back, 8 megapixel front. Okay, for that particular what all processing units I need, let's say like DSP, right, digital signal processing related modules I need, analog to digital or digital to analog conversion modules I need, frequency, pixel rate, each and every module information required only for that camera will be. And again for memory, what all requirements are there, he will be handling it. And based on all this, he will decide, or let's say he will perform a pictorial diagram of your design. Okay, he will create a pictorial diagram of the design. Clear so far? Guys, am I audible?
Yes, sir. Yes, sir. Audible.
Yes, yes, sir.
Okay. Okay. Clear for everyone so far?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Do we get a PDF of all these discussions?
Do you get what?
A PDF of all these discussions?
Yeah, that is with respect to admin. Let's say like once I cover all this particular theoretical part, right? Or let's say the knowledge which I want to share it in the technical stuff. There will be and one more person who will be joining the call to query about all this particular documentation, timing information, and all. Okay.
Okay, okay.
Okay. So now the next is like architect. Once architecture, that means of what all modules I need. So once outline is provided, what is the next step? That means the flowchart is created. What will be the next step? What will be our next step? Flow ready. The next step will be coding. Next level is RTL.
Hello, sir.
Guys, am I audible?
Yes, sir.
Yes.
Okay.
Yes, yes.
So there is a laptop called disconnected. Okay. So till what extent I was audible? RTL coding.
Sir, the screen is not visible.
Yeah. That I'm trying to do because presently I'm connected through my phone.
Okay, sir.
Uh, that's why the screen is not visible. There is something hanging in laptop. Um, okay, so what I was asking is like till RTL coding, everyone is clear.
Yes, sir.
This is not clear. Okay, let's do one thing. My laptop is kind of stuck. Um, I'll restart by the time. Let's take a break of 10 minutes and then we will be back. Okay.
Okay, sir.
Sorry for
Sure.
minutes. So back at 10:40.
Sure, sir.
Sure.
Sure.
Hello everyone. Hope I'm audible now.
Yes, audible.
Okay. Previously we were discussing about the ASIC flow, in which we have started with specifications, architecture, and RTL coding, right? Yes or no? Okay. Once we have written that particular RTL code, okay, what is our particular next step?
Hello, sir. Your voice is low.
Okay, is my voice clear now? Or is it bit low again?
Yes, sir.
Okay, one second. Am I audible now? And my voice is clear?
Yes.
Okay. So previously we were discussing about up to RTL coding, right? So till that particular section, anyone have any doubts? Okay, so guessing no questions. So once that particular RTL code is written out, what is our particular next step? Verification, right? So once that particular RTL code is written out, so on what basis we have written the RTL code? So based on the architecture outline, right? So that means functional verification we need to perform. Okay, once the RTL code is written out, we are going to be performing a functional verification. Okay, so there will be separate teams for it. Okay, but still we are discussing is like complete ASIC flow. This includes like from the scratch to the final chip. What all different stages are there? We are discussing each and every one of them. Okay, it's not like only our particular section. It should be known knowledge for everyone. So that's why I'm touching each and every prospect. Okay, so specifications, architecture, RTL coding, functional verification. So once the functional verification is done and everything is successful, the next we will be we will be having a stage called as DFT. Okay, in this particular stage, this particular steps will be running parallelly. Okay, it is not like one after the other. These particular stages will be running parallelly. DFT, design for testability. Next is synthesis, and next is CDC. Okay, I'll just mention one term before it, STC development.
main crossing, and next is UTF. Okay, so there are multiple stages. I'm not listing each and every part right now. Okay, so till now what we have done is like functional verification. So once the one functional verification is good and they say it's like there are no functional errors, we will go for the next step, that is timing constraints development. So when we are telling timing constraints development, we are specifying about the requirement of the frequency levels. Okay, in timing constraints, we are specifying about the frequency requirements of the modules. Okay, at what, how much frequency the circuit needs to be working. Those information we are going to be sharing about that particular pattern. Okay, the next is DFT. So we want our particular design to be tested after manufacturing also. We want our particular circuit to be tested after manufacturing also. Yes or no?
I mean, for the some extent, maybe yes, but for the working or functionality of the circuit should be checked before the production, I guess.
Yes. So before and after we want it to be checked, right? Because we need to know which particular part of the chip is failing. Correct?
Yeah.
Right. So when we want that particular testing of that particular chip to be done before and after, okay, of manufacturing of the chip, we need a team called as DFT. Okay, what they will try to do is with respect to the RTL code, okay, with respect to the RTL code, they will insert the test modules also. Okay, so few of you have heard already is like during your engineering, ATPG, JTAG, stuck at 0, stuck at 1. So like that few of your terminologies you would have heard during the engineering, right? Yes.
Yes.
Right. So those particular testing levels, right? Those will be developed by this particular DFT. Okay, it's vectors or what all modules has to be inserted and which particular cells needs to be converted to scannable flip-flops. Okay, those will be provided by this particular DFT. Okay, the next is synthesis. Okay, DFT is clear for everyone? Yes, no, this is
This DFT is also including that the writing test spaces on system Verilog. Is that also included here?
no, no, no,
No. Okay. So,
no. Okay, so that is functional verification. On your
okay.
RTL code, writing the test vectors. Test vectors.
Sorry.
Is it possible to have a template for all type of DFTs? For all type of chips?
Yes. So for this particular DFT person, they should be knowing the architectural design, and they on that particular architectural design basis and the connectivity process only, they will try to perform this particular DFT modification. Okay, the templates
Okay.
and everything. If you are trying to learn about this particular DFT process, you will be going in depth of that particular DFT. Okay, but
Okay, got it.
currently DFT is
Yeah.
like knowledge.
Okay, thank you.
Okay, yeah. Present. So the next part is synthesis. So, before going into synthesis, I'll just ask one question. That is like in RTL code, we have this behavioral format. And when I want to make it into a physical view, can I use that particular behavioral code? Can I use the behavioral code to view it in the, let's say, any kind of tool? So, for example, during your engineering, again, most of the concepts for us is touching with respect to your engineering. When you have written any code, you would be trying to see the schematic structure of that particular circuit, right? Yes, no,
Yes, sir. Yes, sir.
right. So when you have written down that particular you have provided us like only Verilog code. For that, I'm able to see the schematic. Now, how the tool is trying to perform that particular task is where our particular basics of synthesis starts. Okay, that is like, and also if you remember, we will try to provide a few of the libraries before writing that particular Verilog code, right? So something like header files and some mapping files we used to provide. And based on that particular mapping files, whatever we are providing, the tool will try to show its equivalent symbolic representation. Okay. So for example, you would have written two types of coding. That is like y equal to a and b. This is one type of coding you would have written. And the next is like and of a comma b comma y. This type of coding you would have used during your Verilog codings, right?
Yes, sir.
So when you are providing this particular behavioral code for the tool, okay, this type of behavioral code for the tool, what the tool will try to do is it will look for its equivalent logic provided in one of an input, and its equivalent symbolic representation will be provided. For example, you have provided a code whose equivalent symbolic representation is not there. Okay, then there will be some kind of errors popping up. There is syntax error, or let's say reduce that particular length of the code. Like that, it will be showing some errors, right? So, whenever we write a behavioral code, we should make sure it's like its equivalent symbolic representation or its equivalent gate information is present. Based on that, only the RTL code will be written. And in synthesis stage, what we will try to do is, as I cannot perform my timing or optimization with respect to the behavioral code, what we will try to do is we will try to convert this particular RTL code or behavioral code to a gate level netlist. Okay, in synthesis, we will try to perform is conversion of, in synthesis, we will try to perform is conversion of gate level, sorry, behavioral code to gate level netlist. Okay, behavioral to gate level netlist. That means converting all the structure which is present in case 1 to its equivalent cell naming present in the inputs which we provide. Okay, conversion of behavioral code. That means this y equal to a and b will be converted to the case 2 and of a comma b comma y in that particular format, everything will be converted. So I'll just keep one more example. Let's keep it examples. Assign y equal to a. What does this do?
It infers a buffer.
I'm trying to make a connection between y and a, right? Or let's
Right.
say the a value, I'm trying to pass it directly to y. Can I say it's kind of a buffer?
Yes, sir.
We can also use a wire.
Sorry?
Can also use a wire.
Yeah. So what I'm trying to do here is I'm just going to convert this particular assign y equal to a as buffer of a comma y. Can I do this? If its equivalent cell name is present. Yes or no?
Yes.
Right. Okay. So this is one of the keys. Okay. So that means your behavioral code will be converted to its equivalent cell name. That means this buffer naming, or let's say the naming of the buffer or the naming of the inverter, the naming of AND gate. So like that, the basic cells or let's say basic circuits which are globally used, we will be having some set of files we will provide. Okay, from that particular set of files, the tool will try to pick its corresponding name and it will provide the output. Okay, I'm just giving this as an example. Okay, assign y equal to a, I'm just converting it to buffer of a comma y. And this buffer naming will be decided based on the inputs which we provide. So during our particular course duration, we will discuss about all this particular input files, what all we need in a bigger flow. Okay, after this particular, and there is a flow for synthesis as well. Okay, internal flow for synthesis. It will be of three different steps: analyze, elaborate, and compile. Okay, three different steps of your synthesis: analyze, elaborate, and compile. So based on this only, the conversion gets happened. Okay, so
So
and
optimization happens in step 2, right?
step three,
Step
compile.
3. Okay.
Okay, so the details, more details of it during the course duration, we will try to discuss about that particular each step by step in detail. Okay, now the next is CDC, clock domain crossing paths. Okay, so when in this particular CDC, we are mentioning that is like clock domain crossing. We have some modules connected, right? So for example, let's say camera module and memory module. Okay, camera module and memory module. So whenever I click a pic using the camera, we want that particular pic to be stored into that particular memory, right? Yes.
Yes, sir. Yes, sir.
Right. So now when now the question is like, will the camera circuit and memory circuit be working in the same frequency or in a different frequency? Okay,
Definitely, it will be different frequency.
different frequencies. So that means my data is getting passed from camera to memory. And as there are different frequencies, now the clocks passing to camera and the clock passing to memory may be synchronous or asynchronous clocks. Correct?
Hmm.
So when we have synchronous clocks, I don't have a problem because there is no phase shift difference. I can be able to easily map that particular data and I can be able to send it. But when these two particular domains are asynchronous clocks, okay, when these two clocks are asynchronous, now what will happen? There will be a phase difference, and because of that particular phase difference, we will be having a problem in capturing the data properly. Okay, so what I want to say here is in CDC, okay, in CDC, that is clock domain crossing, the data transfer between, okay, the data transfer between asynchronous paths or let's say asynchronous clocks will be taken care. Okay, the data transfer between the asynchronous clocks will be taken care in the CDC paths. Clear? So there will be a separate team because we when there are asynchronous uh, clocks, right? We will be having some synchronizers getting present. Okay, in those particular parts, we want some synchronizers to be added. So those what type of synchronous to be added in those particular parts, we have this particular CDC team taking care of. Okay, the next part is UPF. Till now, everyone is clear,
Yes, sir.
Yes, sir.
right? So the next part is UPF. So when we are talking about UPF, in that particular terminology itself, we have is power, unified power intent. So this UPF or CLP team, okay, conformal low power, okay, UPF or actually UPF is a file generated by the CLP with an eagerness I've just written it out, okay, CLP team that is conformal low power, okay, conformal low power team will be helpful for us to reduce the power, okay, dynamic power consumption of the device to be reduced. So you're telling, right, battery backup. Okay, I want is like 12 hours of battery backup. When my phone is in ideal state, I want the battery backup of 48 days. Okay, with full charge and network module off. Okay, that is like internet module to be off. Only calling services. We want my phone to be used for 48 hours or 24 hours, right? So how can I use that particular dynamic power consumption properly? This CLP team will be performing it, okay? For the battery optimization, CLP team, or let's select power requirement, CLP team will be helping us. Okay, clear for everyone? So from this particular part, okay, synthesis, okay, synthesis is a stage where it is an intermediate between your RTL code and your gate level netlist, right? RTL code and a gate level netlist. The synthesis is an intermediate. That means the synthesis output, that is your gate level netlist, is a technology dependent file. Okay, is a technology dependent file. So the stages other than synthesis is called as, up to now whatever we have discussed, the stages before that is called as front end. Okay, the logics, that is like RTL coding, functional verification, DFT, CDC, UPF, CLP. So these terminologies come under category called as front end, FE, FAT, front end team. Okay, so in few industries, okay, in few industries, synthesis is also a FET. Okay, in few industries, SC is also, synthesis is also an FET, front end team. Okay, so don't get confused. So synthesis will be acting as both front end and back end because it's an intermediate stage. Okay, so from synthesis is what your actual flow starts. Back end. The next is physical design, and after physical design, sign off. After sign off, chip manufacturing. Chip manufacturing, and after the manufacturing of the chip, we have is like post silicon validation, and if it is successful, it goes to customer. If it is having a failure, it go back as a feedback to the physical design. Okay, so this is the complete ASIC flow. Is the ASIC flow clear? Any questions or any doubts? Internal to physical design, we have some steps, and sign off also we have some steps. Okay,
Okay, sir.
all right. If you guys have any questions so far, please go ahead. So in now let's go internal to physical design. Okay, so now let's go internal to physical design. So this is where your main part of your physical format of placing the cells, performing the wiring, everything will be present. Okay, in another format, this physical design you can more or less relate with respect to civil engineering. Okay, this physical design is more or less you can relate it with respect to the uh, civil engineering because we are going to be performing the similar steps. Okay. Physical design. Now, let's select they will be working in hot sums and we will be working in ACs. That is what the major difference is. Okay. Similar way of execution will be there. So when we are talking about physical design, the first step, what will be our first step? Planning. Okay, any stage if you go, the first step is always planning. Okay, planning on how to execute the flow. Okay, this is again physical design flow. We have to plan is like how to execute the flow, whether I can be able to perform that particular flow completely or do I need to divide it. Okay, so let me ask a question. If I want you to develop a phone, okay, let's say I'm a customer and you are holding a company, okay, some manufacturing company, you are having semiconductors. So when I want you to develop a phone, will you be able to perform single-handedly or will you take the help of sub teams?
Yes, we have to take help from the other.
We will try to take the help of sub teams. Let's say like because phone is a bigger circuit. Inside that particular bigger circuit, I have is like camera, memory, network, audio and video. Like that, we have different. So if a single person is going to do it, the amount of time which it takes to develop that particular phone will be too high. And
Yes, sir.
right. So instead of developing by a single person, now if I say is like camera modules, I'll assign 4 members. Memory module, I'll assign a person. Okay. So based on that particular level of logic in that particular circuit, the number of person if I assign them and if I perform my flow, will it be faster? Divide and conquer algorithm.
Yes, sir, definitely.
Definitely, right? So this divide and conquer algorithm is called as hierarchical designs. Okay, this type of divide and conquer is called as hierarchical designs. Whereas if I'm able to perform by a single person from the scratch to the end, if only I'm able to do it, okay, then I will be calling it as flat level design. Okay, without the taking or let's say without performing divide and conquer, if I'm enough to perform that particular task, okay, then I will be saying it as a flat level design. Okay, clear?
Yes.
Right. So that's what we will try to perform here again. The first is design planning. Whether a single person again. So RTL code synthesis, I don't have a major issue. But when I go to the physical level, I am going to be performing, let's say, apartments. Okay, when I perform a single apartment or group of apartments, when I go to physical only, I will be able to get more clear picture whether I can be able to do it or not. So that's why the first step will be providing is like design planning. Along with this particular design planning, or let's say before design planning, loading the inputs will say is like input design stage. Okay, loading all the inputs to the tool and performing the planning of how to perform that particular tasks. Okay, and once this particular import design and design planning is done, we'll try to go next is like floor plan. Okay, the next step is floor plan. That is like in floor plan, let's say whenever you want to construct an house, what is the first step you will try to do?
You have to put a base.
Base. Okay, next. So I'll make it
Then
simple. So first is like you will provide that particular, you will consult an engineer, and based on that particular idea which you provide him, he will give you an outer line of your design where which room needs to be placed, all that according to your vastu and everything. He will plan it and give it to you. Yes,
Yes.
yes,
right.
sir.
So in floor plan stage, that again in that itself, we will provide you is like estimation of the area and the shape of the house. Everything will be decided in that particular chart itself, which is preparing.
Yeah.
So in floor plan stage, we are going to be deciding the shape and area of the chip, which we are going to be developing based on the inputs provided. Okay, so this depth concept will be going in when we go to the advanced topics. We'll be understanding about that. In floor plan stage, we will be discussing about the creating of shape and area of your chip or block. And next is like, as I said, right, bigger rooms. First itself, if there are any small scale industry also, if you want to plan, okay, along with parallel to your house, you want to some of your area to be used for your small scale industry. That means you will give a priority of placing those particular uh, devices which occupy more power, right? After that, only you will plan for the placement of the remaining rooms. Yes or no?
Yes, sir.
Right. So, like that, in here also, in floor plan stage, I'll just give it like in simple terms. Deciding the core and die area. So this terminologies only I'm giving. I'm not touching right now. During the advanced sessions, we will discuss about this particular terminologies more. Okay. Placing the ports, placing the macros. And there are multiple steps, so which we will be discussing during our advanced topic. Okay, clear? In floor plan stage, I'm just giving a clear an overview picture saying that my shape and size of my floor plan, that is like chip area, and also interface logics placement. And after that particular interface logics placement, I'm performing the macro placement. Okay. So once this is done, I'll go for the next stages, power planning. So before construction of your house, you should be going and discussion with respect to the power distribution system, right? How the power is going to be distributed to our house and how much amount of power is required, dynamic power consumption requirement. So those particular values, you need to provide it first, such that the room doesn't have a power failure. Okay, so power planning needs to be done before every room starts to be constructed. Okay, before and after we need to perform the checks. So power planning, and the next is placement. In placement stage, we will try to place standard cells. Placing of standard cells. And the next part is CTS, clock tree synthesis, where building of clock tree is done. And next is routing, virtual connections to physical. Okay, and this concludes the PD flow. And the next is sign off. And in sign off, we will be having is like multiple checks going on, and we will be covering is STA, Red Hawk, let's say power analysis. Tools will I'll discuss that. Power analysis, and the next is physical verification. Okay, clear for everyone?
Yes, sir.
Okay. So there are other checks also, so which I'm not writing it. Let's say LEC, ERC. So like that, there are multiple checks. Okay. Sorry. In this particular course duration, okay, in this particular course duration, we will be covering is like synthesis, PNR, STA, basics of power analysis, and basics of physical verification. This we will be covering it in this particular duration. Okay, and the tools which you are going to be using is mostly everything is Synopsys. That is for synthesis. We are going to be using is Design Compiler, and for physical design, we are going to be using is ICC2, and for power analysis, you are going to be using is Redhawk, and for physical verification, we have is ICV, and for timing analysis, we are going to be using is prime time, and the next is like for parasitic extraction, you are going to be using is star. Okay, these are the different tools you are going to be using it, and the technology node which you are going to be using here is one project. Let's keep it like projects. Project one. This project details of complete project. We will try to see it when we start with respect to the labs perspective. But right now, I'm not touching the complete part. Okay. So that is like I'll just give us like only technology node information. No clocking information and no count information will be shared right now. So technology node is 28 nm, and project 2, the technology node is 14 nm. Okay, one project with 28 nm and the one other project with 14 nm. So this is what our particular agenda, and I'll tell a note that is like During the lab sessions, there will be a dedicated mentor who will be handling only one project. The second project, after a certain stage, he will give it as an assignment. You have to do everything by your own with the understanding of the project one, whatever he is handling. Okay, so we make you to do it rather than we provide each and every. No spoon feeding will be done. Okay, so we want you to perform more and each and every task. Okay, multiple assignments and multiple tests will be conducted. Okay, so this is all about the technical information. Any questions with respect to the technical? No questions? Everyone is clear?
Yes, sir. It's clear.
Okay. Okay. So do you guys have any administrative questions? If yes, I'll ask the admin to join right away. Okay, just give me 2 to 3 minutes. I'll ask admin to join. Just give around like 5 minutes. The manager will join the call and he will answer all your queries related to your administration, like timing and interviews, everything he will be able to handle. So, how many of you are experienced till he joins the call? We'll have a little bit of chit chat. Uh, how many of you are experienced?
I mean, not in this field, but industry experience, yes.
Okay. So, you are from which background?
I'm basically from this Verilog initially.
Okay.
Yeah.
Mm. So that means like your knowledge will be very, very useful. That is like you are testing knowledge will be good, na?
Yes.
So yeah, in here the basic principle is like very basic requirement here is like debugging skills is very, very important. Okay, that's what an engineer is, but to be more specific, I am saying that. Okay, so debugging skills is the very, very basic requirement. Okay, so and for those who are going as a Christian, right? Analog and digital to be known. Okay, basics, not advanced. So basic knowledge of analog and digital information to be known, and its manufacturing process. Okay, so just like a revision of all that, it's good to have that. Okay, but when you go as an experience, you might not worry about that. And after a certain level, again you will be touching those particular basics again, manufacturing and everything. Okay, and Only one person is experienced? Okay, everyone is recently passed out or any older pass outs are there? Everyone is recently passed out? 2021.
No, sir. Actually, now I am currently doing my PhD, sir, at
Oh,
VIT.
great. Okay, that's
So I
good.
am doing research on cyber security and hardware security. So I am more interested to gain the knowledge of what backend hardware is done. That's why I took in this course.
Okay, so like chip designing.
Ah, yes, sir. Yes, sir.
That's good. Okay, so you should be knowing Tamil, I guess. VIT Vedur Institute of Technology. Don't worry, I'm a multilingual. So yeah, hello. Uh, Vaibhav? Hello.
Yeah. Hello, this is Vaibhav.
Uh, yeah, Vaibhav, you are audible.
Yeah. So I think we are done with all the technical aspects of the demo session and how the training, what you will be learning with respect to the physical design. So see, myself, I'm the manager of VLSI Guru. I will be taking care of the training as well as the placement. So any questions regarding the schedule as well as related to the placements? Yeah. Can we have a one by one question answers where if you have any doubts, please let me know so that I can provide the relevant answer to it.
Hi, Sir Anthony. Hello.
Yeah, Dilip, you are audible. 1 second, I think
May I know when the regular classes started, sir?
1 second, I think so it's got on mute. So give me a second.
Hello. See, the regular class will start from Wednesday. So basically for a full week batch, I will just share my screen to show you the schedule.
Okay, sir.
Yeah. So all of you are able to see my screen.
Yes.
Hello.
Yes,
Yes,
sir.
we can see.
Yeah. So basically for a full week batch, we will be having a training 6 days per week. That includes Monday to Saturday, 9:30 to 1:30. In this 6 days, this one 6 days course per week, there will be 2 days theory, 4 days labs. In the theory, the trainer will teach you all the aspects like floor plan placement, CTS. With respect to the tool, he will invoke the tool and he will do the hands-on. In the lab sessions, the mentor will be guiding you to where you will be doing the task onto the tool. So that's how you will get a complete hands-on exposure. Now we have another weekend batch. It is specifically for those who are working in some other domain and have a free time only on weekends. So for them, the Saturday, Sunday, there will be almost 9 to 6. The sessions will go in which 9 to 1 will be theory and 2 to 6 will be the labs. Every session that I'm doing, it is getting recorded in the background. Just I will walk you through the our InSkill portal. So once you enroll for the course, you will be provided with the login credentials of our InSkill portal. Once you enroll, as you will be looking for physical design, so this physical design tab will be open for you. When you go inside it, see we have a clear distribution of the videos, schedule, presentations, assignments, and notes and labs. So what happens is now also the demo session that we are doing is getting recorded in the background, both the screen as well as the audio. So in that context, when I do the session, regular session or even it's a weekend session, every session will be getting recorded and you will be having access to each and every recording session. So if I ask a question to all of you, why you want to do this physical design training? Hello, am I audible to everyone?
To work on the backend process, to know the backend process.
Yeah, I am expecting other candidates also to respond. See, basically, if I'm not wrong, the objective of this is about the schedule. Now, the objective of most of you candidates doing this training is to start a career as physical design engineer in industry, right? Or PD engineer in industry. Am I correct?
Yes, I'm not audible. I mean, I can't hear.
Hello.
Yeah, like now I can hear.
Okay. What about others?
I can hear you, sir.
Okay, fine. So, see, the objective of doing the course first is to start a career as a PD engineer. Second, and it eventually correlates to what? Getting expertise in PD. Now, when I say getting expertise in PD is all about tool and technology. Where what I mean by that is on which when you go into the industry, they will be asking about the expertise in the tool because physical design doesn't include any coding. You should have a expertise in the synopsis tools because you will be doing out floor plan placement, TCS, power plan, and the technology nodes, that is 14 nanometer, 28 nanometer. Correct. So this is the company expectation. Now, the course curriculum or the projects that we are teaching are in sync with these industry requirements. So for that purpose, what we do is every session over here, once I do the session, I will start from the basics, then slowly I will move to the advanced topics also. So every session that I am doing, it is getting recorded over here. For you to provide placements and to provide you the job assistance, what is our expectation is Whenever a session is happening, you have to attend the session and learn the things. After a couple of hours of the session, the session recordings will be uploaded into this portal in the format of video. So you have to go through these videos, and the assignments over here are in sync with the topics. With respect to each and every topic, they are in sync. So even we have the notes, presentations, interview preparations. The criteria for a candidate to sit for the placement is he has to complete at least 70% of the assignments, because the assignments are in sync with the most of the interview questions. Once you complete 80% of the assignments, we will start providing you the placement assistance, and the placement assistance will be provided till you get a job. Now coming to again the schedule, this is about the timings in the schedule. Basically the course is divided into two parts, that is 2 months of basics and 4 months of main training. So even I will walk you through the curriculum also. So see, this is the bifurcation that we will be doing, where in the basics we will include disease, VLSI design flow, semiconductor, advanced digital design. In digital design itself, we will be doing almost 300 questions, then Linux, and then TCL. Even the PT flow will be also included. Once we are done with the TCL, it will take around 2 months. We will start with the main training. In the main training, we will be doing the synthesis, the all the parameters that have been shown here, like synthesis, UPF, initial design, setup, placement, power plan. We will be doing all these things. Now see, to explain these things with small examples, it hardly takes 1 month. The reason of keeping this the duration as 4 months is because the projects that we will be doing, we will be implementing each and every topic. For we will be doing synthesis in block level as well as chip level. Even for power plant placement, it will be carried out in both the projects. This is how we want the candidate will get an expertise and will have a hands-on experience on the industry standard requirement. Now coming to the projects, see, uh, once every after 3 months, 4 months, we have the meetings with the companies, understanding their requirements, and then we keep on upgrading our projects. So the project that we'll be doing, it will be more than enough sufficient. Coming to the course curriculum, the syllabus that we are starting, that from digital design, it will starting from AND gate or gate. Now few of the candidates will be there who are pass out year is 2018, 2019, and even there are candidates who are currently ongoing their highest qualification, this one MTech or BTech final year. So we keep the starting line same, where we start from the basics and slowly we will move to the advanced topics. Yeah, so any questions?
Sir,
Coming to
do
the
we
batch,
get sir,
please tell me.
do we get PDFs of the class live lectures?
See, when you go to over here, that assignments and all, these all are uploaded over here, and you will be able to access this notes and all for complete 1 year.
Okay.
And even the live session recordings that we are uploading, every session will be available over here. Like suppose today I have done the session, today's session will be available onto the portal for 10 days.
Okay.
Yeah, any more
Yeah, hello.
queries? Yeah, please tell me.
Sir, actually, my passing year is 2017, and I was working in sales domain. and I want to switch from sales domain to my core branch. Actually, I'm a electrical engineer. My electrical and electronics. My branch is electrical and electronics.
Right. See, we have tie-up with 70 plus companies. Now, when it comes to the hiring, company looks only two things. First one is the criteria, and second one is the candidate having the expertise or not. So,
Yeah.
if a candidate is having criteria, he's 2022 pass out with a CGP of 9 and even 8 something, he is eligible as per the criteria, but he don't have the
Okay.
expertise. Company will not hire him.
Okay.
But
Okay.
if the candidate is having expertise, but they are asking 2018 pass out, but you are 2017, still the
Yeah.
company
Yeah.
can have. Basically, why the company is hiring in a company, they have the projects, they want expertise candidate to work on the project. If a candidate is having expertise, they can consider the criteria. So
Okay.
not
No,
only
actually,
that,
I have an experience in sales domain. I have around 3 year work experience in sales domain. But I
right.
don't.
So basically, I will just give one example. There was a candidate who has completed in 2014 and was working
Yeah.
as
Yeah.
a assistant professor in college. He was withdrawing a
Okay.
package of around 5 lakhs. After 6 years experience, he has switched to VLSI domain with a package of 9 lakhs.
Okay. Actually, I want to know, am I eligible for this or not yet?
Yes, you are eligible.
As you mentioned, the passing year is 2018, so I asked this.
I had just given an example. See, basically the companies that will be coming to me, they will be looking for the expertise candidates. Now, every one of you might be aware that in when it comes to industry, 70% of the hiring happens through reference.
Okay. So
So if you
actually,
have the expert,
physical design is
is
basically back-end process. And
right.
if in future, if I want to pursue my career in front end, so can I switch
Uh-huh.
from physical to front end?
See, VLSI is such a domain where if a candidate is having expertise, company are ready to hire. Now, suppose after 3 years down the line, 110% you will have the expertise and even you are having the VLSI experience.
Okay.
So, no doubt you will be able to switch.
Okay. Okay. Thank you, sir.
Yeah,
So, Vaibhav sir, good morning, sir.
yeah. Very good morning. Please continue.
Sir, actually, I'm planning to do the course on weekends.
Right?
So, when will the course will be starting, sir, for next month?
See, the course will be starting from Saturday.
Okay, sir. Okay.
Yeah,
Okay, sir. Thank you, sir.
sure.
Sir, in all weekdays classes, after weekdays classes, when we are able to access lab and when it is useful, sir.
See, what happens is, let's take an example of a full week training. So, Saturday, Sunday theory session, the industry trainer will teach you 5 to 10 topics. Right?
Okay.
Then, Monday to Thursday,
Hmm.
you will be doing the practical labs.
Okay.
And if you are going for weekends, then 9:30 to 1:30 will be theory and 2:30 to 6:30 will be labs.
Okay. Meaning, theory classes will be in on Saturday and Sunday only.
Right.
Okay. So, for example, from tomorrow, from Monday, there is no theory class. We can access lab for practical purpose and
See,
some
what happens
assignment we can
is
do.
from Monday we are starting, right? So, not Monday, we will starting from Wednesday. So, when we are starting with digital design. Digital design doesn't have any labs.
Okay.
Yeah. Once the modules comes like TCL scripting and all, then there will be a labs that will be for weekend. It will be carried out on 1:30 to 2:30 to 6:30 for weekends, and for full week students it will be carried between Monday to Thursday. Any more doubts? Any queries?
Is same for offline or online classes? Both are the schedule same for both of them.
Sorry?
As you said, the classes schedule will be same
Uh-huh.
for both online or offline classes.
Right. See, now also there are candidates who are attending offline.
Okay.
Yeah. So
If
the
I
offline
want to join
candidate,
the offline classes,
see what happens is the online and offline. All of now, I think all of you has many of you, not all of you, many of you may have got the link through WhatsApp, right? So once you enroll for the course, all candidates I will add into WhatsApp group. Now few of them are from suppose offline candidates. They will be coming to the institute and they will be learning seeing the screen through projector. And candidates who are attending online, the way you are attending now, similar fashion you will be attending.
okay.
Yeah. And any candidate who
Oh,
wants to switch between online to offline, weekend to full week or full week to weekend, everything is allowed. The agenda is you should learn as per your flexibility.
okay, sir. Okay. Thank you, sir.
Any more queries?
Yeah, hi sir, I'm Dilip.
Please tell me.
In classes you're conducting in online. What about the lab, sir? That one
See,
also conducted in online.
right, what happens is even if the candidate is coming online or offline, once the session starts, once we start with the labs also, in the initial 15-20 minutes, everyone has to log in into the server and access the tool. So offline candidate also has to log in into the server. Online candidates also have to log in into the server. So the tool access will be 24/7.
Okay, sir. I'll get the answer.
Yeah. Any more queries? So basically what I will do is we will be starting the course from Wednesday. I will put my contact number. You can also get back to me if you have any more queries.
I have one question. Sorry.
Yeah, please tell me.
I have actually requested for the this analog layout, but I got the link for the PD. Do we have
Okay.
any session for the analog also, like
Yes,
demo classes?
we will be having an analog layout session also. Basically, I will share my number. Okay,
Mm-hmm.
you can reach out to me. We will be sharing you the details of the timing schedule for analog layout course.
Okay, thank you.
Yeah, just 1 second. Manar, can you please come? Where is the chat box over here?
I think you joined
Through app, that Windows app.
that's why that
So,
won't show it. You want chat box?
so
They're sending anything?
I want to no. I have to send messages. No, they might have sent or not sent. I'm not sure. In this,
They're not send anything.
they have not sent anything, no?
You can end the session.
No, no, no. They want my number.
You can send it here.
Every no, no, not here. So I had shared my number in the chat box. Coming to the fees is 63 plus GST, which comes to 74,000. Currently, we are considering 20% discounts for the immediate enrollments. So after discount, it will come to 59,472. 472. Even the installment options are available. So as I had mentioned my number in the chat box, you can get back to me if you have any more queries.
So chat box is not visible to us.
I think I don't see the chat box also.
Oh no.
Yes, sir. Yes, sir.
You are sorry.
So chat box is not visible to us. So where we have to find the chat box, sir?
Okay, do one thing. Can you note down? All of you can note down.
Yeah, that is better, sir.
I will just share and you can note it down.
Yes, please.
Yeah, it is 9986194191. You can contact or even WhatsApp us for the queries regarding the course or regarding the placements also. So if you have any query, you can let me know.
Sure, sir.
Yeah. Any more queries?
Not from my side.
Sir, actually, for payment, you're sending one QR code, right? That QR code we can pay and we can pay through GPay. Then after payment, we have to fill the Excel sheet.
Regarding the payment, what you can do is you just send me a hi on WhatsApp. I will share you the enrollment process.
Okay, sure, sir, sure.
Yeah. Yeah. So we will end the session over here. But as I mentioned that I have shared, I think all of you have noted my contact number. For any queries, please reach out to me. We will be starting a batch from Wednesday. And for weekends also, the batch is starting from the coming Saturday. So the enrollments are open till Wednesday. Yeah. Thank you for attending the session. Yeah. Thank you.
Thank you. Thank you for the brief explanation. Bye.
Thank you, sir.